Hello guys, welcome back to my YouTube channel. So today's topic is human eye. Contents: the human eye, parts of the eye, optical defects, optical corrections, eye as a camera system, bionic eye. Human eye is a sensory organ, part of the sensory nervous system that reacts to visible light and allows humans to use visual information for various purposes including seeing things, keeping balance and maintaining circadian rhythm. The eye can be considered as a living optical device. It is almost spherical in shape with its outer layers, such as outermost white part of the eye and one of its inner layers, keeping the eye essentially tight except on the eye's optic eyes. Parts of the eye: iris, a thin pigmented structure found in the eye that can regulate the amount of light that can enter the retina. It determines the eye color. Lenses, allows the eye to focus on objects at varying distances. Pupil, it is an opening that allows light through the lenses. Sclera, a protective covering that wraps over most of the eyeballs. It gives the eyeball its white color. Cornea, cornea helps your eye to focus light so you can see clearly. Retina, it is a layer of photoreceptor cells and glial cells within the eye. It changes the signal received into electrical signal that your brain interprets as an image. Optic nerve, it relays message from your eyes to your brain to create visual images. Damage to an optic nerve can lead to vision loss in one or both eyes. Choroid. The choroid is filled with blood vessels that bring oxygen and nutrients to the eye. Blind spot. Photoreceptors are absent in this region and hence there is no image detection in this region. Optical defects. Any state of the eye which hinders rays of light from centering one's vision approximately upon the retina. There are different types of defects which occur in the eyes. A few of the optical defects are myopia, which is also known as nearsightedness, hypermetropia, which is also known as farsightedness, presbyopia. Myopia. It is commonly known as nearsightedness. In this condition, the person can see the objects nearby but can't see the distant objects. Symptoms: blurry vision, difficulty in seeing while driving, particularly during night times, headaches due to eye strain. Correction of myopia. When a concave lens of suitable power is used, it assists in focusing the image onto the retina. Hypermetropia. It is commonly known as farsightedness. In this condition, person can see objects at a distance but can't see nearby objects clearly. Usually the person with this disorder squints to see nearby objects. Hypermetropia is caused when the light rays from a close object are focused at a point behind the retina. The condition of hypermetropia is clearly explained in the figure. Symptoms: blurry vision, headaches due to eye strain, squinting. Correction: a convex lens can be used. Presbyopia. We know that along with age, the power of the accommodation factor to adjust the focal length also decreases. People have difficulties viewing nearby objects clearly without the assistance of corrective glasses. This condition is referred to as presbyopia. It happens when the ciliary muscles weaken and diminish the elasticity of the eye lenses. It can be seen in people above the age of 40 years. Symptoms: blurred vision due to aging, headaches due to eye strain. Correction: This condition can be corrected by using proper eyeglasses or contact lenses. Minor surgery also helps in restoring the vision with better clarity. Advancement in technology has made it easy to correct the refractive defects with contact lenses or through surgical interventions. So now let's see optical corrections. It refers to one of the several methods used to improve blurred vision caused by refractive error. People need vision correction to correct a refractive error. A refractive error occurs when the eye does not bend light correctly as it enters the eye, resulting in blurred image. The most common methods of vision correction are wearing eyeglasses or contact lenses. They help achieve clear vision by refocusing light rays on the retina, compensating for the shape of the eye. Refractive surgery is another vision correction option. LASIK is another approach which is normally used. Eye as a camera system. Human eye is a wonderful instrument, relying on refraction and lenses to form images. There are many similarities between the human eye and a camera, including a diaphragm to control the amount of light that gets through to the lenses. This is the shutter in a camera and the pupil at the center of the iris in the human eye. A lens is to focus the light and create an image. The image is real and inverted, a method of sensing the image. In a camera, film is used to record the image. In the eye, the image is focused on the retina, and a system of rods and cones is the front end of an image processing system that converts the image to electrical impulses and sends the information along the optic nerve to the brain. Human eye can be analyzed to a camera system as both the eye and a camera capture light and convert it into an image. In both the eye and a camera, the captured light is transformed into an image by lens and the light sensitive component. The eye processes the image further, allowing for visual perception, while a camera stores the image for later use. It is important to note that the eye is much more complex than a camera and has several additional functions, such as adjusting for different levels of light and adjusting focus, that are not found in a camera. Cornea. This transparent outer layer of the eye functions like a camera lens, bending light to focus it on to the retina. Iris. Iris functions like a diaphragm in a camera, controlling the amount of light that enters the eye. Pupil. Pupil functions like aperture in a camera, adjusting the size to control the amount of light entering the eye. Retina. Retina functions like a camera film or sensor, capturing the light and converting it into electrical signals that are sent to the brain. Optic nerve. Optic nerve function like the cable connecting the camera into a computer, transmitting the electrical signals from the retina from to the brain. So now let's see bionic eye. Bionic eye electrical prosthesis surgically implanted into a human eye in order to allow for the transduction of light in people who have sustained severe damage to the retina. The bionic eye comprises an external camera and transmitter and an internal microchip. The camera is mounted on a pair of eyeglasses where it serves to organize the visual stimuli of the environment before emitting high-frequency radio waves. The stimulator microchip consists of an electrode array that is surgically implanted into the retina that functions as an electrical relay in place of degenerated retinal cells. The radio waves that are emitted by the external camera and transmitter are received by the stimulator, which then fires electrical impulses. The impulses are relayed by the few remaining retinal cells and are transduced as normal to the optic nerve pathway resulting in vision.